As we saw earlier, there's some similarities between sine and cosine. If we were to take in consideration our SOHCAHTOA, we see that both sine and cosine both rely upon the hypotenuse in terms of getting towards their answer. What we'll see shortly is that there's actually another relationship that exists between both items specifically. Let's take this for example. If we have triangle ABC, and what we're going to do is label angle A as our theta, or as we mentioned before, kind of essentially like our reference point. If we're going to have sine theta A, we're going to label the opposite of A as just our A. We're going to label opposite of B as side B and the opposite C of side C. We also know that the opposite of our theta is going to be A. B would be something along the lines of our hypotenuse, and C would be our adjacent side. So, for example, if we were going to do sine theta, that would be equivalent to our opposite side over our hypotenuse side. So that would be equal to A over B. Next, we can describe cosine in reference towards theta. Cosine in reference towards theta is our ka in SOHCAHTOA is going to be our adjacent over our hypotenuse, or our C over our B. And if we were to also express tan theta, would be equivalent to A over C. And notice once again we're dividing by B in sine and cosine. We're dividing by the hypotenuse in both cases. In our previous lesson we talked about we were able to quickly answer the value of C as in it's the remainder of the two angles in our triangle sum theory. In this example what we're going to do is express angle C as 90 minus our theta. 90 minus our reference angle is going to be our remainder angle. If we were to express this once again as sine, cosine, and tangent in reference towards our 90 minus theta, this would be equivalent to our new opposite and our new hypothesis. Cosine, once again, is adjacent over hypotenuse. Our adjacent in reference towards C is going to be BC and AC, or A over B. And if we're going to do tangent of angle C, or that 90 minus theta, we'll end up with C over A. What I'd like you to do right now is take a look at your diagram here that we just filled out and see if there's any relationship between two of our answers. What you'll notice is that there's actually a paired relationship here. We can see that sine theta is actually equal to cosine 90 minus theta, or cosine C. There is a relationship that exists between sine and cosine. They're essentially the opposites. Like, for instance, if we were to take a look at the chart from last week, that long one that kids used to have taped to their tables. If we were to take the opposite values of these, Like for instance, sine 25, and if we went all the way down to cosine 65 and compared it to 25, 25 plus 65 equals 90, they'd end up with the same value. These charts here basically swap values eventually. Reason why they swap values is because if we think about the total of these two angles here, they're complementary. They're both equivalent to 90. So as the triangle itself expands and compresses and expands and compresses, the relationship that exists between those two angles has some type of symmetry with one another. So what we can express here is, in question number 4, what do we notice about sine theta and cosine 90 minus theta is that they have some type of transitive property. In that we can say sine theta is equal to cos, cos, 90 minus theta. These two are always going to be equivalent to one another. One way that we can express this in our own words, and you can rewrite it how you will, but for me the major thing that sticks out here is that term that we've used in the past of complementary. If you don't remember what complementary means, complementary is they sum or they add up to 90 degrees. So if we want to write this out basically as a sentence, we can say that sine and cosine ratios of complementary angles are equal to one another. Sine and cosine ratios, which is that list of numbers that we have that I just showed you from the previous day. These ratios of complementary angles are equal. All right, so what we can do now is take a look as we go down to the bottom of our page, our try it out section. So our first question, we're asked to make a prediction about the value of cos 20 and sine 20 and use your calculator to justify your prediction. So this is a leading question, essentially, we can describe it as, because we can see that cos 20 and sine 70, or 20 plus 70 is equal to 90. If we're to go ahead and start to place these values directly into our calculator, make sure it's nice and focused for you guys. If we do, let's start with cos 20. If we do 20 cos, we get a value of 0.9396. And if we're going to do something like sine 70, clear out our calculator, 70 sine, we get that same value of 0.9396. All right, so take a moment. I want you to take a look at this bottom value here. Take a shot at number 2, looking at solving for the value of x given the relationship described. So to answer this question or to solve for x, we have to come to the conclusion here that we see both sides of this statement are equivalent to one another. We have our equal sign. But how do we go about solving here? The main notion that we have to pick up on is not that 2x minus 10 is equal to 40 itself. It's that combined, they actually equal 90 degrees like we saw in our previous example. So what we want to do here is pull out these particular values. We want to do 2x minus 10 plus 40 is equal to 90. From here, now we just go through and we drill down and we solve for x with algebra. Minus 40, and we add 10, minus 40, and we add 10, which gives us minus 30. We then have a total of 60 is equal to 2x, divide out our 2, and we get a final solution of 30 for just x itself. So now we have question number 3. In question number 3, it states, for a right triangle ABC with a right angle at B, we're told sine A equals 3x minus 5 and cos C equals 8 parentheses 6 plus 5x. All right, so what are we going to do here? All right, so a couple things that we want to do here. First, as always, what we want to do is start off with a nice diagram. So you can always use your compass if you still got it. You can always use another pencil, a pen, something along those lines, but it always helps to have a nice little visual aid. What we're going to do is draw a right triangle, triangle ABC. And we're just going to assume that we got a nice right angle here. So main thing, first off, what I'm going to ask you is why or how are we going to label this? Do I know if I can put A where the 90 degree is? Is it B? Is it C? So in regards to the question here, we're told we have a right angle at B, which is greatly going to help us out. Next, since we want to keep our orientation nice and consistent, we can go ahead and say A, B, and C. Next thing we want to do is go about labeling some of these sides or some of these angles. If sine A is going to be, so after we label our diagram, what we're looking at here is how do we set up an equation? Like what are we going to go ahead and do? If we take a look at our diagram from the top, we saw that sine theta or sine A is equivalent to cos C, or they're equal to one another. We can parlay this into our equation on the bottom, where we can say that sine A is going to be equivalent to cos C. The reason why this is different than question number 2. Question number 2, we're not told sine A, we're not told cos C. We're just told that they are equivalent to one another. We use that notion to then go ahead and add up to 90. Reflexively, since we know that they're equivalent, we can also combine them as well too. So here, we're going to say sine A is 3x minus 5. We're going to set that equal to negative 8 parentheses 6 plus 5x. We then go have to distribute our information. Our left side is going to stay the same. when we have parentheses, remember I have to pull those numbers over to each. Negative 8 times 6 is going to give us negative 48 minus negative 40x. Now we're just going to go ahead and combine all of our values. I'm going to add 40x, add 40x. So we get 43. So we keep our x value positive. We add 5, and we get negative 43. We then divide out our values, and we get a final solution of x is equal to negative 1. For this, it's perfectly fine that we have negative value because we have this negative 8 over here. Right. This is your lesson in terms of your notes for today. This one is a bit faster than our previous days. Going forward, if you have questions, comments, concerns, if you have suggestions and things like that, feel free to contact me, Ms. Henry, Mr. Sampson. We're looking to work and build upon this process with you. So for many of us, it's our first time doing anything like this or in terms of presenting content this way. So we need your feedback. Please be positive and constructive and give specifics if you have concerns or you'd like to see something else. In addition to that, you also have your ability to speak to me every single day with the office hours, and feel free to ask me anything. As always, have a nice day.